So let us see miscellaneous example. So first example is vector A is given in Cartesian coordinate, that is AYX cap plus BXY cap. Take A and B are constants. Now you have an open loop, that is a circular loop in XY plane. This is Y axis of radius R. So what will be closed A dot dl in this case? So let us first see what will happen when you calculate this in Cartesian coordinate. How to calculate this in Cartesian coordinate? So you know that equation of the circle is, what will be equation? X square plus Y square is R square. This is the equation. So you have to relate X and Y. So if you differentiate this, this will give you X dx twice X dx, or finally you will get X dx plus Y dy is 0. 2 will cancel out, or this will, that will relate X and Y. Now in XY plane, you can see dl can be written as dx x cap plus dy y cap. So what will be A dot dl? This A dot dl will be given by A y dx plus bx dy. This is A dot dl. Now in Cartesian symmetry, you have to convert either in terms of x or y. So let us convert this in terms of x only. So you can divide this in two segments. Let's say this is 0.1, this is 2, and this is 3, and this point is 4. So you have segment 1, 2, 3 and segment 3, 4, 1. You have two segments. So consider segment 1, 2, 3. I have taken these two segments because in upper half y is positive, in lower half y is negative. So according to this relation, y has two values, plus minus under root r square minus x square. So for upper half y is positive, so take y is plus under root r square minus x square. And you can also convert y into this, dy can be written as, what will be dy? From this relation, minus x dx by y. This is dy. So now A dot dl for upper segment, you can see y is under root r square minus x square dx plus bx, and dy is minus of x dx by y. Y is again root r square minus x square. So you have converted A dot dl in terms of x only. So you have two terms. So what will be this integral? Integral A dot dl segment 1, 2, 3. So this will be given by, what will be limit of x? Just see, what will be limit of x in this case? So let us first simplify this expression. This you can write as, this is A r square minus x square minus b x square by under root r square minus x square dx. So you can write this as, take, this will be A r square minus a plus b x square by root r square minus x square dx. You can write in this form. So finally you will get this integral. Limit will be, what will be limit?
सर ये क्या ले
I have rearranged in this form. This is ar square, take minus x square common, you will get a plus b. So this is the final expression, a dot dl, in terms of x only. So you have to integrate these two terms.
Sir,
So-
dy.
dy is, I have written here x plus dx is plus y plus dy is 0. So dy is minus of x dx by y. And y you have to take positive value for upper segment. Y is this value, plus root r square minus x square. Is it clear?
Yes, sir.
And then limit, let's say limit along this segment. At this point, this is
R2 minus
plus r and this is minus r. So plus r2
Minus.
minus r. Limit of x is plus r2 minus r, and you have these two terms, ar square minus a plus b x square by root r square minus x square dx. Finally, you have to integrate this. So you have to see this integral. This integral is 1 by root r square minus x square, and this integral is x square by root r square minus x square. So you must know how to integrate this. These are the standard form. I will write its final result. You have to verify it. So what will be integral? 1 by root r square minus x square. So ar square common. 1 by root r square minus x square is sine inverse x by r. Integral 1 by root r square minus x square dx is sine square x by r. And x square by this value is minus a plus b. If you integrate x square by root r square minus x square, then this integral will be, you have two terms, minus x by 2 root r square minus x square. You have to verify these integrals, plus r square by 2 sine inverse x by r, and then limit will be plus r2 minus r. Finally, you have to integrate this. That will give you line integral along upper segment, segment 1, 2, 3. So you have to put the limit. So if you put the limit, you will see this term will be 0 because this is r square minus x square. If you put x plus minus r, so this term will be 0. And what is sine inverse x by r? So if you write this integral, I am writing here. So this term will be 0, and this will give you, this integral is, this is a square r minus of a r square by 2. This, take this 0. Now you have a r square by 2, and then minus b r square by 2 sine inverse x by r, and limit will be plus r2 minus r. Finally, you will get this result. Now take separate a plus b. So a into r square by 2. So sine square x by r common. Similarly, b term is minus b r square by 2. So integrate this. Put these limits. So this will be, finally you will see, this value will be r square by 2 common. So that will be a minus b. And what will be sine inverse x by r? So this is sine inverse minus 1 and minus of sine inverse 1. So this will give you minus 2 pi. This is minus pi by 2 and minus pi by 2. So this is r square by 2 a minus b. This integral is minus pi by 2, and this will be also minus pi by 2. So this will give you minus pi. So you can write this as pi r square by 2 b minus a. This is for upper segment. Segment 1, 2, 3. This is for upper segment.
So
Pi r
right
square. Yes.
जो फर्स्ट लाइन है ऊपर उसमें a स्केयर r नहीं आएगा ना, a r स्केयर आएगा वहां पे
कहाँ पे?
राइट साइड में जो आपने लिखना शुरू करा है उसकी फर्स्ट लाइन
a r square. ये this is a r square.
हाँ जी,
This is a r square because term is a r square. ठीक है? So now you can see this integral is for segment 1, 2, 3. Similarly, you have to find for segment 3, 4, 1. So in that case, y will be negative. Is it clear? Segment 3, 4, 1. So for this segment, y will be minus of under root r square minus x square, and limit will be, integral limit will be minus r2 plus r. If you integrate, limit will be minus r2 plus r. You have to write a dot dl, these terms, and then integrate with respect to x. So again you have to verify. So if you calculate this, you will get finally this value is same value. That you have to verify. Pi r square by 2 b minus a. You have to verify this in same manner. Y is minus root r square minus x square. So you can easily convert a dot dl in terms of x. Limit will be minus r2 plus r. So for upper segment and lower segment, you have same value. So closed a dot dl will be, you have to add these two. So if you add 1 and 2, segment 1, 2, 3 and 3, 4, 1, this will give you pi r square b minus a. Add segment 1, 2, 3, 3, 4, 1. Both are pi r square by 2. So if you add, you will get pi r square b minus a. Is it clear? Is it clear or not?
Yes, sir.
But if you know symmetry, you can simplify your calculation. No need to do this, because you can see circle has cylindrical symmetry. You can see if you have objective question and you have to find closed a dot dl, you have to do these steps. This is for upper segment. You can see this integral, how you will integrate this, then put the limit, and similarly for segment 3, 4, 1. So it will take time, you will get same result. But we can simplify our calculation if you can use the symmetry of the surface. So in this case, this circle has cylindrical symmetry. So we will, now let's see using symmetry how you can simplify your calculation. So let us compare this with cylindrical symmetry. So we can redraw this as in this form, because in cylindrical symmetry, you have to show circle in xy plane, and this is the z axis. So this is the circle. Radius is r. So now you know it has cylindrical symmetry. So first write down a dot dl. So dl will be dx x cap plus dy y cap, and then a dot dl will be ay dx plus bx dy. So that you have to do in Cartesian coordinate. You can easily do this, but we can easily convert this in cylindrical coordinate. How you will convert? You know the conversion. X is r cos theta and y is r sin theta. So what will be dx here? Minus r sin theta d theta. Theta is phi here. That theta varies from 0 to 2 pi. You can take it as phi also. Let us take this as phi. Take it as phi. This is phi. And what will be dy? R cos phi d phi. So now A dot dl will be A into y. Y is r sin phi, and dx is minus r sin phi d phi, plus bx is r cos phi, and dx is bx dy. So dy is, you have a y, y is r sin phi, and dx a y dx. So dx is minus, ठीक है, this is, and what will be dy? bx
R cos phi d.
r cos phi d phi. So this will be minus a r square sin square phi d phi plus b r square cos square phi d phi. So you have easily converted this into A dot dl in cylindrical coordinate. Then now you can directly find closed A dot dl. So this will be minus a r square sin square phi d phi. Limit will be 0 to 2 pi. You can see in circle limit will be 0 to 2 pi. And br square cos square phi d phi, this will be 0 to 2 pi. So integrate this. What will be integral sin square phi d phi 0 to 2 pi? You can convert sin square phi and cos square phi in cos 2 phi. And then integrate. Sin square phi is 1 minus cos 2 phi by 2. And cos square phi is 1 plus cos 2 phi by 2. If you integrate this, both will give you, this integral value is pi. You can easily verify. So finally, closed A dot dl is pi will common, pi r square is common, you will get b minus a. You can see same result. So result is pi r square b minus a. Now you can see these steps. You can easily calculate. So if you compare with Cartesian symmetry, it is easy to calculate in cylindrical coordinate. Yes or no?
Yes, sir.
Yes, sir.
So you can write down note. Now your main aim is to simplify your calculation using the symmetry. That is the purpose of the studying these symmetries and in these theorems, divergence theorem, gradient theorem, or Stokes theorem, that you can simplify your calculation. That is the main purpose. So if vector is given in Cartesian coordinate, and symmetry of the surface is cylindrical, use cylindrical coordinate system. Use cylindrical coordinate system. So you have to remember this point. If you want to simplify your calculation, whenever vector is given in Cartesian and symmetry of the surface is cylindrical, always use cylindrical coordinate. That will simplify your calculation. Is it clear or not? That's why I have calculated in both symmetry, in Cartesian as well as cylindrical. Now you have to decide whether you want to calculate in cylindrical or Cartesian. ठीक है?
Excuse me,
Yes, sir.
sir.
Yes.
Sir, how can we decide that the symmetry is given in a cylindrical coordinate or and this?
Now you can see, you know
Coordinates.
the cylindrical symmetry. So you have to relate with cylindrical coordinate. You can see this cylinder, this circle has cylindrical symmetry or not. You are on the surface of cylinder, so you are moving on a circle. So whenever you are moving in circle, circle is in XY plane, that has cylindrical symmetry. I have discussed cylindrical symmetry. Spherical symmetry, whenever you are on the surface of a sphere, that is the spherical symmetry. That you know what is cylindrical symmetry and what is. Can we apply spherical symmetry here? It's a cylindrical symmetry because you are on the surface of a cylinder. And if you are on the surface of cylinder, you are moving on a circle. That is the cylindrical symmetry. I have taken this Z0. This Z is 0. So it has cylindrical symmetry. That you know. You have to just distinguish between cylindrical and spherical symmetry. And that you can easily distinguish. Let's see next example. Let us see vector A is some constant A naught Z cap. This vector is given and you have a hemispherical surface. XYZ, its radius is R. So you have to find what will be surface integral A dot dA over the hemisphere. Over the hemispherical surface, find this integral A dot dA. So this vector is in, that is same in Cartesian as well as cylindrical. So you can see vector A is in Cartesian and symmetry of the surface is spherical. You are on the surface of a sphere. So you can use spherical polar coordinate. In this case, this direction is R cap. So this is R is equal to R surface. So on R is equal to capital R, what will be dA? Capital R square sine theta, d theta d phi R cap. So what will be A dot dA? R square sine theta, d theta d phi, and this will be A naught Z cap dot R cap. And you know what is dot product of Z cap dot R cap? Z dot R cap, that is cos theta. So convert this into spherical symmetry. So we will get R is A naught. This will be A naught. Z dot R cap is cos theta. So this is sine theta, cos theta, d theta d phi. So you have converted A dot dA in spherical polar coordinate. So now integral will be A naught R square by 2 common, take it sine 2 theta. So this is sine 2 theta d theta d phi. Theta will be 0 to pi by 2 and phi will be 0 to 2 pi. So calculate this. So this integral will be A naught R square by 2 sine 2 theta is minus cos 2 theta by 2, 0 to pi by 2, and d phi will give you 2 pi. So what will be this value? Cos pi, this will give you 1. So 2 will cancel out. So that is pi A naught R square. This value will be 1. So you will get pi a
Negative
naught
value.
r square.
It's negative value, sir.
No, positive value, because cos pi is minus 1.
Sir,
Cos pi is minus 1. You can
Pi
easily,
by 2.
this is cos 2 theta. So if you put theta pi by 2, 2 will cancel out. So minus cos, that will be, this is minus cos pi and then plus cos 0. What will be this value? By 2. So this is 1 plus 1 by 2. This will be 1. You can easily check. Okay? So again you can note down that when vector is given in Cartesian and symmetry of
sir,
the surface,
z cap dot r cap.
this is cos theta. In spherical symmetry you can check. I have written, when you have transform a vector from one system to other system, I have written these terms. What is z dot r cap, x dot r cap, y dot r cap, even with theta cap and phi cap also. So simplest is z cap dot r cap, because angle between z cap and r cap is theta. You can check. Okay? So again you can note down that when vector is given in Cartesian and symmetry of the surface is spherical, use spherical polar coordinate.
सर इसमें हमने सेकंड सरफेस नहीं लेना.
I have given you that you have to find on the hemispherical surface only, that is the open surface.
ओके अगर क्लोज होगा तो दोनों लेना.
Then you have to find on both surface. I have given you just on the surface of the hemisphere.
Okay.
This is the open surface. Now let us see next example. Let us take a scalar function is given x, y, z square, and you have two different volume. This side is 1, this side is also 1. This is the cubical volume. This is A part, and you have B part also. In B part, this volume is a prism. Again, this side is 1, this is 1, and this is 3. So this is B. It's a cubical volume and it's a prism. In both cases, you have to find volume integral f d tau. Let us calculate f d tau in both cases. So how we will calculate f d tau? So you can see f is given in Cartesian, symmetry is Cartesian, so you can easily calculate. First calculate for A part. So that will be x, y, z square dx, dy, dz. This will be origin. This will be 0 to 1. Y will be 0 to 1 and z will be 0 to 3. So calculate this limit. So this integral will be, with respect to x, you will get x square by 2. So that is 1 by 2. Y will give you y square by 2, 1 by 2. And this will give you z cube by 3. 3 cube by 3. So this value will be 9 by 4. So volume integral over this cube will be 9 by 4. Now find same volume integral for this prism. Let us calculate. For B part, f d tau. So this limit will be this is x y z square dx dy dz. Now what will be limit of x y z? What will be limit of x y z in this case? So in this
0
case, you can see now x and y are dependent, and z
Y
is,
equals 0 to 1 minus.
so x and y are dependent. So what will be the relation between x and y in this case? In xy plane, intercepts are 1. So we will get x
X
by 1,
plus Y is equal to
y
1.
by 1 is 1. So or you can see x plus y is 1. So x and y are dependent. So accordingly, let us take z 0 to 3, x 0 to 1, and then y will be 0 to 1 minus x. So calculate this integral because x and y are dependent. You can convert either in terms of x or y.
Sir, can you make that point clearer?
Now you have to compare these two volumes. In this case, in xy plane, you have a square loop. So in a square loop, x and y have same dependence. But now in xy plane, you have a triangle. I have discussed one example in last class. So in a triangle, x and y is dependent. So you have to find equation of this straight line. What is the dependence? So that dependence is x plus y is equal to 1. So that's why you can convert either x into y or y into x. So
Sir,
Z0,
Z is independent
x and y are dependent.
or Z?
Z is independent. Z is directly 0 to 3. Z is 0 to 3.
Okay.
So if you integrate with respect to z, z cube by 3. So this is 3 cube by 3. And let us first integrate with respect to y. So y will give you x, y square by 2. So that is 1 minus x whole square by 2 dx. So this will be 9 by 2 integral 0 to 1. So what will be this value? 1 minus x whole square is, this will be x, 1 plus x square minus 2x. So this will be x plus x cube minus 2x square. So if you integrate, this term will be x plus x cube minus 2x square dx. So 9 by 2, this is x square by 2, x power 4 by 4 minus twice x cube by 3, limit will be 0 to 1. So this will be 9 by 2. So 1 by 2 plus 1 by 4 minus 2 by 3. So what will be this value? 9 by 2
1 by 12.
by 12, 6 plus 3 minus 8. So what will be this value? This will be 1 by 12. So 3 by 8. So in this case, this volume integral will be 3 by 8. Is it clear?
Yes, sir.
Yes.
Now let us see another example. These are some miscellaneous example. Let us see. Vector A is,
Sir,
yes,
sir, 3 के power 3 is 9.
3 power cube. So 3 will cancel out. That will give you 9, and 2 is 1 by 2 is common.
Okay,
Z cube by 3.
okay, sir.
This is X, Y.
सर हम
Yes.
हम जगह 1 माइनस x स्टार्टिंग रिप्लेस कर सकते हैं क्या?
1.
1 minus y is equals to 1 minus so they can we
That will
replace
give you
it in
same
the
relation.
starting also?
That will give you can convert either in terms of Y or X. Both will give you same result. You can easily verify. This is the triangular surface. You have to find what will be surface integral del cross A dot dA over the triangular surface. Let us find this value. Calculate del cross A dot dA over the triangular surface. So in this case, what will be dA? So dA over this surface is, this direction is n cap, and this area element will be dA over this surface. So you have to first find what will be dA vector, n cap vector. What will be unit vector normal to this plane? So I have discussed.
Cap.
So first you have to write equation of this plane is x by a plus y by 2a plus z by a is equal to 1. And you know, when you have a constant plane, you can easily write unit vector, take it as some scalar constant f. Let's take it as this constant is v. So what will be unit vector? Gradient v by mod of gradient v. So let us find unit vector normal to this plane. So gradient v is given by, what will be gradient v? So that is 1 by a plus 1 by a x cap plus 1 by 2a y cap plus 1 by a z cap. So this will be 1 by a x cap plus 1 by 2a y cap plus 1 by a z cap by under root 1 by a square plus 4a square plus 1 by a square. So what will be this value? A will cancel out and you will get this will be 2 plus 1 by 4, 8 by 9. So that is 2 by 3. So A will cancel out. Finally, you will get this is 2 by 3 because this will be 9 by 4. So you can multiply numerator with 2 by 3. So 2 by 3 x cap plus y cap by 2 plus z cap. A will cancel out because 1 by a square will give you 1 by a. So A will cancel out. So this is the unit vector. Now what will be curl of A? Let us calculate curl of A. Calculate curl of A. You can easily find what will be curl of A. Y z cap.
X cap, sir.
This is x cap. You can easily calculate. So what will be del cross A dot dA? So del cross A dot dA will give you, this is x cap dot dA dot n cap, because dA vector is, this dA vector is given by dA n cap. So n cap is 2 by 3 x cap plus y cap by 2. This is dA n cap. So n cap will be 2 by 3 x cap plus y cap by 2 plus z cap. So that is simply 2 by 3 dA. This is 2 by 3 dA. Is it clear? What now? But this dA is on the tilted plane. So how you will calculate in this case surface integral? So whenever you have tilted plane, now you have to find, you can take projection of this plane either in xy plane or yz plane or in xz plane. So I will take projection in xy plane. So let us take, if you take projection of n cap along z cap in xy plane, so this will be the projection. And in xy plane, area element will be dx dy. So we can write this dx dy will be given by, take projection of this along z. This direction is z cap. So if you take projection of n cap along z cap, you will get projection in xy plane. So that will give you dx dy. Is it clear? Whenever you have tilted plane, you have to remember this step. You have to take projection in different plane. So I have taken in xy plane. So this will give you dA n cap dot z cap, and then you can write dA in terms of x and y. So that is dx dy by n cap dot z cap. And what will be n cap dot z cap? Dx dy. If you take dot product with z cap, you will get 2 by 3. This will be simply 2 by 3. N dot z cap is 2 by 3. So now you can see this del cross A dot dA will be 2 by 3. dA is given by dx dy by 2 by 3. So this will cancel out. This is finally dx dy. So this integral will be now in xy plane and area element will be dx dy. So final integral del cross A dot dA is integral dx dy in xy plane. So finally you have to calculate this integral. And what will be area in xy? This dx dA will give you simply area of the triangle in xy plane. And you know area of the triangle, that is simply half A into 2A. So this will cancel out. That integral will be simply A square. Is it clear?
Yes, sir.
So you have to remember these steps. In case of tilted plane, you have to take projection. Otherwise, it is difficult to calculate it.